Hello, I'm Mirdad Simkhani, your calculus professor, and this is about U substitution, which is a technique for finding integrals. It is also called change of variable method. So let's look at some examples. This problem may not be too difficult to figure out. We know derivative of e to the x is e to the x, so we're finding an antiderivative, but there is a coefficient 3x here. So if we start with e to the 3x, what is the derivative of e to the 3x? It's 3 times e to the 3x. That's by chain rule because you have to multiply by derivative of the inside function, which is 3x in this case. But there is no 3 there. So if we put a coefficient of 1/3, then that 3 cancels out, and that's what you get as derivative. So derivative of 1/3 e to the 3x now is e to the 3x. And of course, this is an indefinite integral, means we are finding all antiderivatives. So the most general answer would be to add c plus c. So let's see how this works in this method, which we call U substitution. We know that integral of e to the u du would just be e to the u plus c, because the derivative of e to the u with respect to u is e to the u. So we just changed the variable x to u. But here, the exponent is 3x. So if we put a 3 here and a 1/3 outside, because you can move the constant coefficients outside the integral, so that does not change this integral. So the value is still the same. But here, if we let u be 3x, so that gives us the e to the u in that formula. And then the question is, what is du? So the du is derivative of 3x times dx, which is 3 times dx. So this here is the du, and that is the u. So that's how it changes to that formula. And then once you write it as e to the u plus c, then you substitute u back. And then the 1/3 that you made the adjustment stays in the answer. So let's look at another example. So here we have integral of x e to the x squared dx. So I'm going to choose u equals x squared. So then du would be 2x dx. Now if we make the substitutions, then this becomes the integral of, again, there is no 2 here, so I need to have a 2x here, so therefore I have to put a half in the outside. So now the 2x and the dx, that is 2x dx, so that gives me the du. And then you have e to the x squared, and x squared is u, so it's e to the u, and there's a half in the outside, and that is half. Antiderivative of e to the u is e to the u and then plus c. But then you, at the end, you change u back to what it was in terms of x. So to give the answer to the original question, it would be half e to the x squared plus c. So that's the antiderivative of x, e to the x squared. Let's look at another example. Here I have e to the x times sine of e to the x dx. my u substitution is u equals e to the x. That one, I want to replace this to have sine u. And then du is e to the x dx. So notice that e to the x dx, that is the du. So now the integral becomes integral of sine u du. So now it's just in terms of u. And we know antiderivative of sine u is minus cosine u plus c, which is minus cosine of e to the x plus c. And that is the answer to that integral. Here's another example. We have integral of tangent x dx. We don't have a formula for any of the derivative formulas that give you tangent x as a derivative. So we can write this as, if we write it as sine x over cosine x dx, then we can use u substitution. So I'm going to let u be the denominator. So u is cosine x, and then du is minus sine x dx. So that gives me this integral equal to the sine x dx is minus du, and the cosine x in the denominator is just u. So now I have minus integral of du over u. We know this integral, and that is minus ln of absolute value of u plus c, which is minus ln of absolute value of u is cosine x. So that's this plus c, and that is the final answer. So here's one more example. In this example, I'm going to let u be x squared plus 4. Then du would be 2x dx. And here I don't have a 2x dx, but I have x dx, so I need a 2 here. Therefore, I have to multiply the whole thing by half. So now this becomes 1/2. Make the substitutions. 2x dx is just du divided by cube root of x squared plus 4, which is u. And this I can write as a power. So I have 1/2 integral of u to the power minus 1/3 du, and use the power rule. So that's 1/2. Derivative of u to the minus 1/3 is to add 1 to the exponent, and that gives me u to the 2/3, and then I have to multiply it by 3/2, so divide by 2/3, and then plus c at the end. So the final answer is 3/4 u, which is x squared plus 4 is raised to the power 2/3 plus c. And this concludes the video.